Hey, so I'm Amanda, and this is Precision Measurement, Section 2, Unit 4, 91 Echo 11 Echo, ELOC, or Charlie, LSA 3. So, Introduction to Precision Management. This chapter discusses precision measurement. Precision measurement is finer than 1/64th or 1/100th of an inch, or 500 thousandths millimeter, or 1 degree, usually between 1/10,000ths and 1/10,000,000ths and 10,000ths and 200 millimeters, or 5 minutes, or 1.5 degrees. Precision tools, mainly they're delicate and they're expensive, and they must be treated with care. The terminal learning objective: measurement systems and machine tool math in a classroom environment after demonstration of sample calculation using visual aids, the course SOP, and the student handout. The standard: students must complete all critical performance measures during practical exercises. Practical exercise questions with 100% accuracy as described on Student Performance Assessment 91 Echo 112 Echo within 2 attempts. So let's talk about micrometers. So parts of a micrometer that you need to remember is mainly the anvil, the spindle, and the thimble or sleeve and barrel. Do notice on this figure that the frame is a C shape. This one looks to be a 1 to 3 inch, maybe a 1 to 2 inch micrometer. Notice the marks over there where the words point out thimble. This would be an inch micrometer. It converts the numbers to inches or decimal points for inches. There's a optional lock between the spindle and the sleeve of the barrel, and then a optional ratchet stop. So what I don't want to see in the classroom is students grabbing hold of the end of the ratchet stop or the thimble and spinning it around like a windmill or a flag. Again, these are very delicate. They do require service to make sure that they maintain their precision. Notice that the anvil is a permanent fixture to the frame, so it's the spindle that's going to be going in and out when you do your measurements, and you'll be rotating those with your thumb and your index finger at the thimble to get your precision measurement. You want to make sure that your anvil and your spindle stay parallel to the piece that you're measuring. This is a outside micrometer. So you're measuring outside of your circular stock. You can do it on circular stock, but there are other micrometers that measure that, mainly square pieces that we're going to be using in the shop. So I want you to remember your machining language. So when you have your size and dimension, for example, the first one is 1.245. Make sure that you're reading it or speaking it as 1 inch, 245 thousandths. Or you could just say 1 inch, 245. The same thing with the next few that we're going to go over. 0.137. Which is mainly just, we don't have to say 0 inches, but 137 thousandths, or 137. The next one, 0.755 or 7588. That would be 758 and 88 and 8 tenths. I'm sorry. So 758 thousandths, 8 tenths. The next one, 3.25. So we're looking at the first decimal place, or before the decimal place, being 3 inches. So that would tell us our micrometer should be a 3 to 6. So we have 3 inches, and then we go into our decimals, 250 thousandths, or just 3 inches, 250. The next one, we would use a micrometer that would go from 0 to 3, or 1 to 2, or I'm sorry, 0 to 1 or 0 to 2 micrometers. So 0 inches, don't have to say that, it'll just be 100 thousandths. The next one, 0.32, 320 thousandths, or just 320. And then the last one, 0.2204, so we have 220 thousandths and 4 10 thousandths, or 220 and 4 10 thousandths. Okay, so when we're looking at our micrometers, we're looking at the top left picture. So our 100 thousandths are a horizontal number line. Some of them go from 0 to 9. Some go they have a double line. So you'll have numbers on the top that indicate inches, and then the hash marks underneath the horizontal line closest to the spindle will be your 100 thousandths. So again, if we look at the top left picture, the 100 thousandths is done, each tick mark inside the whole numbers there are 25,000 increments. And then your 10 thousandths and thousandths is on the thimble, so not the sleeve that we're discussing, but the thimble. Again, still in the top left-hand picture to the right, the 10 thousandths and the thousandths, that's your thimble. And it is done in 1,000 increments. And then to read your tenths, up at the top in that same picture, the 1, 2, 3, 4, those are your tenths or tenths of a thousandths. The picture on the bottom is showing you how you take the inches, so the 5.0, reading the top line of your barrel, and then underneath that horizontal line is your hundredths, your 100 thousandths, and then your thimble designates your 10 thousandths and thousandths. So as you can see there, we are past the 5, so we have 5 inches. And then we look at the tick marks below the horizontal line on the barrel or the sleeve, and we are a little over 500 thousandths. So then we reflect onto the thimble and see that the lines line up horizontally with a tick mark that puts us at 28 10 thousandths. So we add the 500 thousandths, so we add the 100 thousandths and the 10 thousandths, and we get 78. So therefore we have 5 inches, 780 thousandths. Let me move on to our inch micrometer readings up to 1 10 thousandths. So if we look at alpha, okay, we have 25, so we're less than 1, so we have 25 hundredths, and then it lines up the tick mark on the thimble at 0.015, so we should have a total of 40 10 thousandths. Okay. And then you'll just we'll work ourselves through this. So my students will continue to discuss how we're measuring, or how we're calculating the pictures that we see. They're also located in the book on page, let's see, inches, so page 121. And we just go through each one of these. So again, Bravo is at 100 thousandths. We look at, that's on the sleeve on the barrel, and then we look at our thimble, and we have 5 10 thousandths, so it should be 105 10 thousandths. And we'll go through all of those. And that puts me at my time limit. I am Amanda Larson, and thank you.